Hello, everybody, and good afternoon, good morning, and good evening, depending on where you are joining from. Thank you for joining us this afternoon for our live demonstration of Lineardraft. We're really excited to showcase how the software is transforming the way overhead line equipment design projects are delivered. During the session today, we'll walk you through what Lineardraft is, the real-world impacts it's already having, and some of the commercial and project case studies that highlight its value. We'll also take a closer look at how the software supports sustainability and decarbonisation across the rail sector. We'll dive into a live demo where we'll explore structure creation and smart tools, automatic allocation and data management, wire management, design efficiency and productivity tools, views and user comfort, and finally, key features like levels, design catalogues, and project settings. Throughout the demo, you'll see how Lineardraft delivers innovation by moving OLE design into a new era with automation and intelligent tools, sustainability by reducing waste, errors, and rework while enabling smoother project delivery, decarbonisation by supporting the electrification of rail as part of the wider transition to net zero, and efficiency by helping engineers and designers and installers save time, cut costs, and deliver projects more effectively. We'll wrap up with a summary. The question section will be open throughout this session today, and we'll answer any questions throughout. Any questions that we don't get to today, we'll follow up with a Q&A to everybody in the coming days. Thank you very much. I'll hand over to Matt, who can get us started. Matt, over to you.
Hi, thanks, Adam.
No worries.
Hi, everyone. Okay, so before we show you how Lineardraft works, it's important to look at the way overhead line design is typically carried out today and why it creates so many challenges. The first major issue is time. Manual OLE design is incredibly labor intensive. Every clearance check, every wire run, every mast position, and every overlap has to be worked out and drawn manually. And when the route changes or civil rolling stock constraints shift, it means the extensive rework. Manual input of data then only adds to this burden. Iterations are slow and valuable time's lost. The second issue is accuracy. With so many calculations, drawings, and standards to cross-check, the risk of human error is always present. A small mistake in tension, stagger, uplift, or clearances can have major safety implications. And with data being entered and re-entered, the chance of transcription errors only grows. Third, there's integration. OLE design has to tie in with track alignment, civil structures, signaling, and power. When designs are done manually, it's hard to quickly test a change against those other disciplines, and that often means clashes with bridges, tunnels, or gantries aren't picked up until much later when they're then costly to resolve. Change management is another big pain point. If a project scope shifts, designers are forced to manually update drawings, models, and spreadsheets. That's where inconsistencies creep in, and then rework costs escalate. There are also limitations in how designs can be communicated. Manual 2D drawings only give a partial picture of how OLE equipment interacts with the railway environment. It makes constructability reviews less effective, and it's harder for construction teams and stakeholders to then clearly see intent compared to those of 3D or BIM-based outputs. Compliance is equally challenging. OLE design is governed by strict standards, but manually checking every element against those standards is slow and error-prone. And when regulations update, large volumes of existing work may need to be rechecked, which again adds further delays. Finally, manual design methods struggle with data reuse. Information is often locked in static drawings or isolated files, making it difficult to reuse for simulations, construction planning, asset management, or digital twin initiatives. That means duplicated effort later on and missed opportunities to really add long-term value. So, in short, manual OLE design can be slow, error-prone, difficult to coordinate and costly to maintain. And that's the exact set of challenges that Lineardraft was created to solve. With that in mind, let's look at the tangible, real-world impact of what happens when teams move away from those manual processes and onto Lineardraft, not just in theory, but in practice. On a recent project, a tier one organisations working on a major electrification project in the UK reported a 45% reduction in their design costs, a 6-month reduction in the programme of design, and incredibly 0 design-related site visits. And that's a substantial saving in time, resources, and operational effort. Another customer highlighted the even broader benefits, stating that with the additional and wide-ranging impact Lineardraft usage had, we were able to calculate significant savings over a project's full life cycle, which is huge not only financially but in terms of carbon reduction. This demonstrates that the value of Lineardraft extends beyond the design team. It touches procurement, construction, maintenance planning, and long-term asset management. By reducing manual design effort, iterations, and rework, Lineardraft improves coordination across disciplines. Civils, signalling team, and power distribution can all rely on accurate, consistent data, reducing clashes and delays. That means faster approvals, smoother construction reviews, and fewer unforeseen issues during installation. The impact on sustainability is also clear. Avoiding site visits reduces travel emissions. Minimized rework reduces material waste and embodied carbon. Accurate first-time designs mean fewer errors to correct later on, contributing directly to decarbonisation goals and sustainable project delivery. And finally, the improved data integrity allows for long-term benefits. With consistent, reliable design data, projects can feed into simulations, digital twins, and maintenance planning systems. This extends value way beyond that initial design phase, creating measurable lifecycle efficiencies. In short, Lineardraft doesn't just speed up design, it transforms how projects are delivered, creating financial, operational, and environmental benefits across that entire project lifecycle. So with that understanding of the benefits, I'll now hand over to Sarah, who will demonstrate exactly how Lineardraft achieves these results in a live demo of its key features.
Well, thank you, Matt. I'll just share my screen, one moment. Okay, so hopefully you can all see that. So like Matt said, I'm going to walk you through a live demonstration of the software. Now, given that we only have limited time, I won't be able to cover every single feature, but I will focus on the key functionality that really highlights what Lineardraft can do, and particularly its intuitive design and how it can make your workflows more efficient. So one of the key features of Lineardraft is the ability to simultaneously create, edit designs in both the 2D and the 3D. So hopefully you can see on my screen, on the left-hand side, I have my 2D layout, and on the right-hand side, I don't know if it's flipped for you guys, on the right-hand side, I have my 3D model. So whether you're adding, modifying, removing structures, wires, all of the changes are instantly reflected across that 2D layout and the 3D model and in the asset data behind the scenes as well. So like I've just said, as you can see, I've got both my plan view, my 3D view. So I'll keep both of those on the screen as I'm kind of going through the different functionality, so you can see the live changes in each one, regardless of where I make the change. So let's get started then with just some of the basics. So I'm going to go ahead and place a structure. So if I just move my model a little bit. So as you can see, I've already got a marker, a circle marker placed just using ordinary MicroStation functionality. And this marker will indicate the location that I would like my new structure to be placed. So let's get straight into it. So if I go ahead and click place, I select my marker to indicate that that's where I want the structure to go. If I was going to place a portal, I might want 2 markers in there, so 1 for each mast, but I'm going to go ahead and place an STC today. Once I've selected that marker, I just need to choose the left and right rail of the track or tracks that I want to associate with that structure. So I've just chosen this track here. Go ahead and click place. And immediately what we have is the edit structure window has appeared. You can see in my 3D view up over here, I've got a preview that's already started to come together. And in my 2D view over here, I've also started to get a little preview. Okay, so I'll just go ahead and give that a name. And then the next thing that I need to do, I can give it a distance along the track or a chainage value if I'd like to. But the next thing I need to do is to choose the type of structure that I want to place. So I am going to choose an STC, but just to show you the range of structures you can place, we've got in here a TTC, so 2-track cantilever, SSAs, wall attachments, general attachment points. And if I had placed 2 markers, Lineardraft would have recognised that I'm wanting to place 2 masts, and Lineardraft would give me the option of placing a portal as well. So moving on from there, then I've chosen an STC. Now I need to configure it. So you can see this window is broadly split up into 2 main sections. So we've got the mast configuration at the top here, and then we've got the foundation configuration at the bottom. So we'll get started with that mast. So first thing to do is choose my type of mast from the drop-down menu. Now, this drop-down menu is displaying all of the masts that are available to me based on the design catalogues, which Tom will talk about shortly. Based on the design catalogues I have active in this model. I can filter this list using these buttons here, so filter by the design catalogues, and I can search in there as well if I know the name. So I'm going to just select that top one. I can then start to edit that mast, so I can increase or decrease those lengths, and you can see in that little preview over here that it will automatically show you the changes that you are making. I can edit the bearing, and then I can edit the recos and refos. So if you're not familiar with those terms, recos is the running edge of the rail to the center of steel. Refos is running edge of the rail to the face of the steel. So essentially we're looking at the offset from the track there really. One final thing just to really look at is if I hover over that length box just there, this will give you a bit of a preview of some of the ways that the software will support you as you are designing. So if I've hovered over there, and based on the mast that I have selected, it's showing me that I can place that mast in this range of lengths, so anywhere between 3.6 meters and 12 meters, and I can place it in 0.2 meter increments, so it will be going from 3.6 to 3.8 and so on. So if I show you that there. Moving down into the foundation configuration, then it is set up very, very similarly. And this is a pattern that you'll see throughout Lineardraft, is this kind of familiar workflow, so that once you kind of understand how to use one window, you'll be able to use them all. So it is a nice intuitive piece of software. So I'll choose my foundation from the list. Again, this depends on the design catalogues that I have installed. I am able to filter that by catalogue again. And this list of foundations is also based on the mast that I've chosen as well. So only masts that are applicable with that, only foundations that are applicable with that particular mast. If I had chosen a combination that required an adapter plate, so a mast and foundation that needed an adapter plate, this section here would also become available to configure. We can then edit the top of foundation. Right now it is set to the high rail level in that particular location by default, but we can change that or reset it. The gap is the gap between the top of the foundation and the base of the mast, bearing and then length, of course, as well. Now, if I wanted to, I could leave that structure there. I can click update structure, it will save it to my model. I'll get my 2D annotations. However, what I would like to do is just demonstrate that we can use this particular window to streamline our workflows and to do a lot of things all in one place. So I'm going to go ahead and attach some wires to this new structure simply by going over to the Wires tab and then clicking Attach. So next I've been prompted to select my wires. So as you can see, I've already got some wires in my model. And I will just click directly on that wire in the model. I can choose it from the drop down if I would like and search it, but it's nice and easy for me to just click directly on the one that I want. So immediately what we see then, I'm just going to move these a little bit so that you can see a little better. And I'll zoom in. Okay. So immediately what we can see is we've got an edit wire dialog. And the first thing I can do is change my support type. So right now it is supported and registered. I can change that over to be an MPA. I can change it to be an anchor. You can see that my preview is updating all the while. So I'm going to leave it as supported and registered. Next then is to choose the track that I want it associated with. Now you'll remember when I placed this structure, I only associated this particular structure with this one track. So I've only got the one to choose from here. Had I used a portal or a TTC, I would have more than one, would potentially have more than one track in this list to choose from. But we've also got a little bit of the data as well visible there. So we can see the cant of that track and we can see the track level difference. Next, we can configure that wire a little bit more. So we can choose our contact wire height, system height, messenger wire height, and our stagger. And the system height and messenger wire height are dynamic. So as one increases, the other one will too. Once again, if I wanted to, I could leave this configuration here. I could just have my mast and just have it kind of noted that it has this particular wire attached to it. However, we want to do a little bit more of a detailed design. So we're going to then go and add some equipment simply by clicking that equipment toggle. So what we have open up here then is what we call the equipment editor. And because I have used an STC, I've just got a mast as my only choice where I can add that wiring equipment to. If I had a portal, in this list, I would potentially have two masts and a gantry where I can add that equipment to. But we'll just go with the STC and a mast just to keep this nice and simple for today. So I've clicked on that mast. I can do a little bit of editing at this point as well. So I can edit the reach, I can edit the length of my mast. But what I'm going to do is add a bracket. So immediately, my bracket's been added to the equipment pathway and I can start to configure that. So again, very familiar setup in terms of the window, in terms of how we select things. We'll simply choose our we'll simply choose our bracket from the drop down. And once again, we can filter these as well. So I'll go ahead and choose a type C. It is worth noting as well that these brackets that I can choose from here are filtered already by my choice of steelwork. So whatever mast I've chosen here, I will only be able to select from brackets that are allocable with that mast. So it kind of reduces the noise for you while you are designing, kind of stopping some of those errors where you may have, I don't know, a completely inappropriate bracket being attached to the wrong mast. It kind of reduces some of that noise for you. Once we've decided on our type, we can then, if there are options to do so, change the location of that bracket and the rotation of that bracket as well. And that will depend on the particular bracket that you've got. Moving on then, you'll see a default slot has become available. And this is where we'll choose the wire support. So you can see immediately my preview has updated. We've got a wire support on there. And that's simply just showing me whatever was top in this list for wire supports. So I can choose the type. And then I can go ahead and choose the style. So pull off or push off. And then down here, we have further customization. So this section really depends on the design drawings of this particular wire support. If in the drawing there is lots of different moving parts, lots of customizable options, they will be reflected in here. If it is a particularly limited drawing where there is kind of only really one way of setting it up, it will be limited in this section here. But for example, we can change the registration arm length. It's also worth noting as well that the wire supports that we see are directly based on the brackets that we've already got placed as well. So once again, reducing that noise. Now, I'm very conscious that I've just done all of that. It's all gone nice and smoothly. I've not made any mistakes or anything like that. But I just want to give you an example of what does happen, how the software will kind of support you if you do try to place something that might not be quite right. So I'm going to go in and just artificially change my reach, actually make it much smaller. Okay, and what you see is if I go back to this default slot, it's telling me that there are no wire supports available. If I hover over that, now I'm conscious that you might not be able to read that if your screen's quite small, but essentially what this is doing is this is suggesting some changes that I can make to my setup to ensure that a wire support, an applicable wire support, becomes available. So this is saying to me that if I increase my reach to 2.245, I will be able to place a C99 M01. Okay, so what I'll do, go back in, increase my reach, and you'll see immediately that has become available. What I'll do now, I will leave this particular structure editing here, so I'll save it to my model. You see the wire now appears in the window, and I click Update Structure, and immediately what we have is our structure box annotations are in our 2D layout. We've got our structure symbol down here. We've got our stagger, and we've got our nice 3D model as well. So you can see all of that. Oh, my mouse is going a bit wild there. Okay, so next then, I'm conscious that I've just talked all the way through that, and it has taken a good few minutes for me to place that, add the wires and things like that. When in reality, if I'm not giving you commentary, there is a really, really, really fast process. So what I'm actually going to do is I'm just going to repeat that process. I'm going to place a brand new structure, attach some wires without talking through it. So you can just see in real time how quick it actually can be. So if you just excuse me for a moment, I will get on with that. Okay. And there we are. Literally, it's under a minute to be placing brand new structures. Okay, perfect. So the next thing I'm going to do then is to give you a bit more of an idea of just what we can do in terms of using that edit structure window that I've just been using to make even more extensive edits to our structures, and to really show you how your workflow can be streamlined, because we can do all of these things as a part of one workflow. So I'm actually just going to go and find a different structure to work on for the time being. Excuse me. Okay, so let's have a little look at this one. All right then. So I'm going to work on this structure here. So we've got a portal with some terminating anchors attached. And as you can see, I've got one back tie, already attached to this structure. So I'm going to open that edit structure window again, click on this particular structure, and this time I'm going to add an additional back tie. I want one on this mast as well. So I'll go over, so this is the window we were working in before. You can see, because I'm using a portal this time, we've got a gantry in there and we've got a right mast as well. We've also got those adapter plates in here as well, so you can see those. But I'll go over to the ties and struts tab to show you just how quick and easy this can be. We've already got our back tie attached to our left mast, so I'm going to go ahead and add one to our right mast. And again, that familiar window style to kind of make sure that this is nice and intuitive for you to use. So I can choose my back tie type from the top. I'll go with that one. I can then set the style if there are multiple styles available in the drawings, so I'll go with that one. And then I can choose the height that I want that particular back tie to be attached to that mast. So you can just alter it using the up-down arrows. So then we've got our positioning. So right now you can see that my back tie looks like it's in the wrong direction. So the easiest way for me to move this around is simply, right now it's going 4.5 meters along the track. What we want it to be doing is going the opposite direction, so just using a minus number instead. Nice and straightforward. Now, what dynamic positioning means is that the back tie will be placed parallel to the track, and then all we need to do is set our distance value in meters away from the structure. We can be a little more granular than this. We can turn dynamic positioning off, and we can use coordinates and a bearing to really pinpoint that back tie position. But I'm going to carry on using dynamic positioning. Foundation configuration works in exactly the same way as an ordinary foundation, just with the addition of a base plate to add in there as well. So I'll just make that a little longer. And I'll go ahead and click finish. So now you can see in the window, we've got a back tie on our left and right mast, and you can see them both in the 2D preview and the 3D preview. The next thing I'll do, so you've noticed I don't need to save it at this point. I can continue working in this window, so I can continue with that nice workflow. Next thing I'm going to do is add an ornament. So if I just zoom in on there, you can see my left mast already has an anti-climb guard attached to it. I'm going to go ahead and add one to my right mast, and it's as easy as clicking add, selecting anti-climb guard from the list of available ornaments. If there are location and rotation options with that particular ornament, you'll be able to set those, and you can set the height at which you want it on the mast as well. And you can be able to see in here, we've got a preview for that. We do have some non-graphical ornaments as well. So for example, you might have a nameplate that you need to say is attached to a particular structure, but ultimately when construction get there, they're going to place it wherever is best suited on the day. So we do have some non-graphical ornaments purely for that reason, really. I'll click finish. And what you'll notice then just here is we've got a green dot next to ties and struts and a green dot next to ornaments. And that is just indicating to me that I've made changes in both of these sections that have not yet been saved to my model. There is one final thing that I just want to have a little look at in this particular window, and that is looking at our annotations. So the way that, so if I just zoom out a little bit there, I'll just cover that up for now because we want to look at this side. If I just look at our annotations on our 2D layout, you can see they are very uniform. So the way that these look, so whether or not you want this to be a circle or however you want these to look, is defined in what will be your project settings, and Matt will talk about those at the end. In a moment. So they are very uniform because they've all got default settings applied to them. So we can see we've got a default distance offset from our structure. We've got a default look for them, a default positioning. But we can go in and make edits to these annotations on a structure by structure basis, which is especially useful if you are very tight on space, and having this big annotation box just here might not be the best place for it. You might want to move it around. So still in this window, then we'll go to the settings, and we've got a few different options then of what we can do with these annotations. So we can change the scale, so I can make it smaller, I can make it larger, and you can see the preview there. We can change the orientation. We can turn off certain sections of the boxes so that they're not visible anymore. So if you wanted that annotation to be completely gone, you can just turn them off. And then we can also do things like move the annotation, so update the offset. We can rotate the annotation. And then we can, of course, reset those back to their defaults as well. So I will just put that back to the way it was, so it all looks nice and matching. I'll click Update Structure. And all of my changes will have been applied to my 3D, my 2D, and to the data in the background as well. It's also worth just mentioning that we can edit the annotations using our annotations section of the toolbar as well. But on a structure by structure basis, the easiest way is using those settings. Okay, so I'm conscious that so far we have been looking only at these two particular views. So we've been looking at the 2D and the 3D full model views. But it is worth mentioning that we do have some alternative views as well. So we've got our full model views. We also have an all levels view. So if I just show you on there, so that essentially turns on all levels, so the 2D and the 3D all in one place. But we also have the individual structure views as well. So for example, if we go here, go to front, click on a structure, and immediately what we can see is essentially a cross-section view of that particular structure. And these are this is the view that will be saved to then later be put into your cross-section drawings or your annotated elevation drawings. So we have the cross-section view, which is looking down the track at this particular structure. We have the back view. We have left, so looking at it from the left-hand side, right, and then we have top, which is a nice bird's eye view, nice top-down view of that structure. And it is worth noting that you can make any edits you want in these individual views. So if your design is really crowded, or you just want to block out that noise from the rest of the design, you're able to do so in here as well. Now, I did just mention that this cross-section view, this front view, is the view that we would save to then add to our cross-section drawings. Now, in Lineardraft, you don't need to go in and save this for every structure. We can manage them all together nice and simply. So I'll just show you very quickly how to do that. So we'll go to multi-edit, and that will open up by default in the saved views manager. And on the left, we essentially have a list of all of our structures in the model. And then on the right, there is a status of that saved view for that particular structure. So you can see that many of mine are already up to date. I've already got a nice saved view sorted. There hasn't been any changes to those structures since I last saved the views, but I do have a few that are uncreated. So that's those two STCs I made at the start. And if I scroll down, you can see that a few of my portals as well are out of date. So the easiest thing to do here is simply click this button up here, and that will select all of my out of date and not created structures. So all I need to do then is click Update Save Views, and you can see it's doing its job in the corner, and that's it, done. You now have a saved view for every structure in that model, ready to then be pulled out and put into your cross-section drawings. Okie dokie. So just to move on from there then, I've talked a little bit about the fact that we have data that is continuously updated with every click. So every time we make a change, every time we add something new, the data in the background is constantly being updated. So what I will do now is actually just show you some of that data, show you what is available. And yeah, we'll have a look at that. So all I need to do is open up my element information. I will click on this particular structure here. And I appreciate that this might be a little bit small on your screen, but essentially what we have is this structure section. Sorry, I'm in my own way there. We have this structure section here, and within here is all of the data for that particular structure. So we have the coordinate data, we have the foundation data, so we have the length, we have the bearing, we have the allocation data. And if I was to go in and make a change to that, so change those foundations, this allocation data would automatically update when I've clicked Update Structure. We have the mast data, so the length, the allocation, the bearing, and then down at the bottom there we have the track data too. If I open up this information for a wire, you can see just how detailed it is for the wire as well. So we have wire length, we have every single wire point along this particular wire, the data for its stagger, contact wire height, system height, messenger wire height, radial load, and then down the bottom we've got every single span. So the span length, the number of droppers in there, the distance along that span that particular dropper will be placed, and the length of that dropper as well. So the data behind the scenes is extensive. However, you can also add your own custom asset data. So if I just go back to that structure there, if you look at the top here, I don't know how much you can actually see on your screen, but at the top here, we've got some custom asset data that I've already added. So we have asset owner, installation date, and line. And I'll show you very quickly how you can add your own custom asset data to your structures. So back in that multi-edit tool, this time opening the data manager, and you can see those three properties that I've already imported are there, and I'll just remove them for a moment. Now, all you need to do to import your own custom asset data for your structures is simply import a CSV file, and there is full details on our help center on how to configure that file. It is very, very simple, but literally all you need to do is import. So I'll go in there, I will select my file, click open, and then immediately Lineardraft has read that file and identified three properties that are going to be applied to my structures. Now I don't have to include all of them, I can delete them if I decide that I don't want them. But yeah, nice and straightforward, nice, quick and easy way of adding your own custom asset data to your model. Okay, now we've looked at adding a structure, adding some wires, we've looked at that edit structure window, the data. What we'll do now is look at some of the automation tools that will really speed up your workflow. So our two main automation tools are really our copy tools and our move tools. So we'll start with the copy tools. Now, I won't demonstrate every single one because if I demonstrate everything, we'll be here all day. But I will just give you a breakdown of how some of these work and demonstrate a couple. So we've got three different options. We can copy, and this works very, very similarly to placing a structure in that we will draw a marker to indicate where we want that new structure to go, and then choose our left and right rail and make an identical copy of that first structure in that new location. It will be its own unique structure, but it will just be a replica of that original structure, so same setup. We then have copy opposite. Let me choose an STC. We then have copy opposite. So for example, if we have a look here, I've got an STC on this side. If I wanted to make a copy of this to be on this side, essentially a mirror image on the opposite side of the tracks, this is the function I would use. And all I need to do is select my structure and then choose the new left and right rail. Finally then is the multi-copy tool, and this is probably the most powerful of our copy tools, and I'll give you a quick demonstration of how this one works. So I will actually just delete those couple of structures that I made before. They're in my way. Okay, so we'll go to multi-copy then. So multi-copy is a way of copying one structure multiple times at set distances along your tracks. So I'm going to select this TTC just here. And I'm going to make 3 copies of this TTC just because it'll keep it nice and straightforward on the screen for you so you can see it all in action. And you can see immediately in the 2D and the 3D, we have got some preview markers, which is indicating where those new structures will go. So my count is 3 because I want 3 new structures. My name increment is what I want this name to increase by. So right now, my original structure's name is TTC 721. If I increase it, if I have a name increment of 2, they will then be 23, 25, and so on. Distance along rail is as it sounds, it's how far apart we want these structures. So if I just decrease that to 40 and you keep an eye on those markers, you'll see those markers are indicating that new location. I'm actually going to keep it at 50, keep it nice and tidy. And then what we've got is the foundation height. So right now it's set to relative. So what this means is that foundation height will be relative to the high rail level at each of these new locations. So doesn't matter if it's significantly higher in one place, your foundation height will be relative to the high rail level at that particular location. I can turn this off and have it fixed. And what that will mean is that foundation height will be exactly the same in every location. Regardless of high rail level, it will just be exactly the same as the original structure's foundation height. So it's up to you what you use there. At the bottom then, we have our options for what we want to copy. We can leave it like that with nothing enabled and just copy the steelwork of the structure. We can turn on copy wires and just copy the structure and the wires. We can alternate staggers so that with each structure, the stagger is alternated. We can copy the equipment, so the cantilevers, the wire supports will be copied over too. And we can alternate push off and pull off. So with each structure, it will alternate between push and pull. Now I am on a little bit of a bend in the track, so I am going to turn off alternate staggers and alternate push and pull. And then the last thing really to just quickly mention is this secondary structure option at the top. So if, for example, I had another structure on the opposite side of the track that I wanted to copy at the same time, I could simply enable that and then choose another structure. But since I am working with a TTC that goes across both of my tracks, I will just leave it at that. I'll go ahead and click copy. And what you will see is in the 2D, immediately we have all of our annotations immediately created with their new unique names, unique location information. And then in our 3D, we have our 3 brand new TTCs with their equipment attached. So with the auxiliary wires, with the catenary wires, their equipment, all in there. It is also worth noting as well that doing that multi-copy has also added in my span and verse sign annotations as well. Okay, moving on then. The other main automation tool that we use is the move tool then. So again, I will just talk you through a couple of these. So the move tool works very similarly to placing a structure and to copying a structure, in that we will place a marker and select the structure that we want, place the marker, and move that particular structure to that new location indicated by the marker. Multi-move then allows us to move multiple structures at once by a set distance along the track. So by a distance of your choosing along the track. We do have a lot of users who use this feature for moving groups of structures. So for example, if they wanted to move an entire overlap, they'd be able to select all the structures in that overlap, providing that they are single mass structures or attachment points, and they'd be able to move them down the track or up the track by a set number of meters. So there's no need for that manual rebuild of structures simply because something is placed in the wrong position. We're able to just move whatever we need using these features. Lastly then, we have the move to coordinates tool. Now this is especially useful for moving structures to new coordinates, as it suggests. So when you receive your data, your coordinate data back from construction, and they have said, actually, all of these foundations had to be placed in these specific locations due to whatever reasons, you've got these new coordinates, and you're able to make that move using this feature rather than having to go in and move every single structure. So all you would need to do is import those coordinates, so that coordinate data, using a CSV file. So I'll just show you how to do that. So I've clicked Browse, I've got my as-built coordinate data, open, and immediately Lineardraft starts working there. So you can see I've got green ticks. So what Lineardraft has done is it's read that file, it's identified that some of the coordinates some of the coordinates are going to move particular structures. We can see the difference in the X coordinate, Y, Z, and the overall change as well. And we can show those coordinates, those new ones here. You'll also notice down the bottom that I have some warnings. So this one in particular is saying there are no structures that match this coordinate. Now this will be to do with my settings up here, so my tolerances. So right now, Lineardraft will only recognize a structure from its new coordinates if it is within 1 meter of those original coordinates. So what I will just do is I will just slightly alter those tolerances, and we'll move it up to 1.4 meters, fine. And what we can see now is that Lineardraft has identified that all of those structures are within those tolerances. We've identified the new coordinates for all of those structures, and I can go ahead and click Move. And Lineardraft will do all the work for me. I don't need to manually recreate or replace my structures. Everything will move for me. Now, it is worth noting that if, for example, I were to move those movements with those coordinates were to mean that a piece of equipment may no longer be applicable, for example, it's made the reach bigger or whatever, if there is an applicable alternative piece of equipment, Lineardraft will automatically make that change for you as well. So provided that you go in and maybe do a little bit of your own personal check-in, everything will be done for you using that one tool. Okay, so I'm conscious I've been talking for quite a while. There's not much left of this. I've got 3 more things that I want to look at, but now we're going to look at wire management. So we've been looking at structures and we've been looking in depth at the edit structure window, but what we're going to do now is look at wires and how we can edit wires on the as a whole and entire spans of wires. Before I do that, just a quick overview of the toolbar up there. So new will create a new wire, so be that catenary wire or be that an auxiliary wire, so things like your earthing wires. Delete will obviously delete your wires. Copy will allow you to copy your wires and the equipment, if you choose, from one structure to another. So that's really nice if you've got a particular setup somewhere in your model and you think, actually, I would like to replicate that on this particular structure that I'm using down this end of the model. You can use that copy function there. We've then got split, which allows us to take one continuous wire run and split it into 2 consecutive wires, 2 new wires. Join then is the opposite, and that allows us to take 2 consecutive wires and merge them to create one continuous wire. Okay, so let's then take a look at this function here. So this is the edit wire window, and this allows us to edit wires on the whole. So I'll open it up and show you what we're talking about. So all we need to do is select the wire that we want to edit. I'm actually going to choose a different one. Okay, and so immediately it has opened up in the wire points tab. So we've got a list of every structure that is attached, that wire is attached to. If I, for example, click this little, it's like a little square button, you'll see this throughout the software. This will center my view on that particular structure. But yeah, so we've got every structure that is attached to that wire. We've got some of that data at that structure, so the contact wire height, the system height, the messenger wire height, and the wire support as well. From this window, we can detach any of those structures from the wire. We can detach them all. We can attach that wire to a new structure, and we can rename that wire up at the top if we want to as well. Moving into span types then, this is a really nice example of where the data behind the scenes is actually brought into the UI. So in here, we have a list of every span in the model. So we've got the starting structure and the ending structure. We've got that data that we've seen just before. And then we have this new data as well. So we've got system height change, contact wire gradient, the length of the span, and the number of droppers in the span as well. These drop downs then, these allow us to change that span type. So right now I've got this particular span here set as an open root span. If I were to change that to an Arthur Fleury neutral section, for example, what we then will see is our dropper count has actually increased. So Lineardraft has recognized that a change to that span will actually mean that we need more droppers in that particular span. And the data behind the scenes will have updated as well. So the length of those droppers, the distance along the span for those droppers will have all updated simultaneously. Okay, next section then is our in-span equipment. So if I just zoom in nice and close on this particular structure, so you can see that I already have attached to this wire, which is the one that we're working with, I already have some in-span equipment on there. So I have a termination insulator. So what I will do is I'll click on that just to show you how easy it is to add and edit these bits of inspan equipment. So again, very familiar kind of pattern with these windows. We can choose the type of inspan equipment we want. Again, able to filter those out, search directly in there as well. And then we've got the distance value here. So right now it's set to ratio. Just to give you an idea of what that means, if I was to set that to 0.5, for example, that would mean that that particular piece of inspan equipment, that termination insulator, would always be at the midpoint of that wire because it's set to 0.5. Regardless of if I increase that span length, decrease that span length, it will always be set to that midpoint. If I have it on absolute, so I'll just put it back to where it was. If I have it on absolute, that is saying it is 2.2 meters away from this starting structure. If I were to change the span length in any way, it doesn't matter. This will always be placed 2.2 meters from that starting structure. So it's entirely up to you what is best for your setup. The last section then takes me to the next thing that I really want to talk about. So we've got status just here, and I can set the status of that particular piece of inspan equipment just using this drop down. So I will leave it as proposed for now. So I'll go ahead and click apply. You can see again, those green dots tell me that some changes have been made that aren't yet saved to the structure. So I'll go ahead and click update wire. Okay, so the next thing then that I want to talk about is statuses and levels. So Matt will talk to you in more detail about statuses and levels when he talks to you about project settings. But essentially, in Lineardraft, you will have a default status, and that default status will be the status that all of your structures will be set to automatically when you create them. And depending on that status will depend what level your structure will sit on in your microstation. So for example, at the moment, my default status is set to proposed, and based on my project settings, that means that all of my structures at the moment are showing up in red. It might be that your default status might be more appropriate to be existing, for example, if you are doing a renewals project. But like I've just said, just my default is set to proposed. Now, that is a default. That doesn't mean that they can't be changed on a structure by structure basis, depending on your design. So if I go into the edit structure window again, and if I click on, let's go for this one here. And then if I go into statuses, I can then change the status of that structure. So right now it is set to proposed. I can go in and change that to modified, for example. And right now, everything that is attached to that structure will also end up with modified as its status. I can be a little more granular than that, and I can go in and decide, for example, that I want the bracket. So right now it's set to inherit from structure, but I can change that to modified. I can then go ahead and apply that status to everything that is attached to that bracket as well. And what will happen is when I update that structure, it will be placed on a modified level. Let me just move that out of the way. It will be placed on a modified level, and it should change color as well, in line with however my project settings are set up. Okay, so if we zoom in on that, you can see my bracket is now in blue. and blue in my project settings indicates that it is modified. If I just hover over that, I can see the level that it's on is EP supports UM for modified. We can do similar thing with the wires as well, wire points. Go into the statuses in that edit wire window, and we can set the status for the wire point. So if I click modified there, that will then change the status for that wire point, but it will also change the status for the span as well. And we've got more information on the logic behind those span statuses on our help center as well. So if I just click update wire, and we'll see that wire has turned, that span has turned blue to indicate it is modified. Okay, so Matt will talk to you a little bit more about project settings and about statuses and levels. So the last thing I want to talk to you about is reports. So throughout the demo, I've touched on the rich data that is captured behind the scenes. We've taken a look at it in the element information. We've seen bits of it in the UI. But what's really important is that you guys are actually able to extract that data. So the way that Lineardraft kind of allows for this is using the reports tool. So if I've opened that up, we've then got a little drop down with all of the available reports that will pull that data out of Lineardraft. So we've got the raw data, which is a JSON file, and that is essentially all of the data in your model as a JSON file. We then have a series of templated Excel reports. So we have auxiliary and catenary wire validation reports. We have dropper schedule, foundation details, per structure allocation, which is essentially a bill of quantities, and then structure details as well. So I will just generate one of these simply by clicking generate, saving it to my preferred location, and then I can open that up directly from there. Okay, and what we can see then is the data that's held in that particular report. So we've got start and end structure, system height, start and end, span length, the droppers, the distance those droppers along that span, and the length of those droppers. If you are interested in the particular data that is held in each of these reports, they are all detailed on our help center, which is publicly available. So please do go and have a look at that. You just need to type in Lineardraft Help Center. We'll put a QR code on at a later point in the demo. But yeah, they're all detailed on there. Okay then, that then brings me to the end of my demonstration. I know that was a lot to take in. I was talking very fast, doing lots of things on the screen, but really we have just only scratched the surface of what Lineardraft can do. There is lots and lots and lots more to it. So please do have a look on our help center. Please do ask us some questions. Yeah, and I will now hand over to Tom, who is going to talk to you a little bit about our design catalogues. So thank you all very much.
Thanks, Sarah. I'll just share my screen. Okay, so over the next few slides, I'm going to be talking about design catalogues and how they're made. With that said, I'll start with what does the term design catalog mean? So a design catalog is a file that contains all of the components necessary to represent a particular design range in Lineardraft. These catalogs can contain a variety of components from masts and foundations all the way to catenary cantilevers and auxiliary wire supports. You'll have seen many of these item types during the live demo just then. The catalog also contains all of the item linkages that dictate what components can be used together, and these linkages can also connect items across catalogs, allowing multiple catalogs to be used together for a single design. So As we saw in the live demo, every catalog item that's placed in Lineardraft includes a range of data, which can be extracted using the reports that were also demonstrated. And with that, I'm now going to talk a little bit about what catalogs we currently have available. So as you can see from the list on screen, we have a variety of catalogs available covering a number of regions. For the UK, we have UK Master Series, CCAT, Clever, Series 1 and LME. These catalogs have been used on projects such as Fife Electrification, Wales and Borders Electrification, Midland Mainline Upgrade and the Transpennine Route Upgrade, just to name a few. For France, we have V360, which was used for the outline design of High Speed 2 in the UK. For Australia, we have PTA, MTM, and also an Australia General catalogue, which contains some generic steelwork for use with the other Australian catalogues. These catalogues were used on projects such as the Morley-Ellenbrook Line and multiple projects as part of the Southern Programme Alliance. And then finally, for New Zealand, we have Auckland and Wellington. I don't have any specific project names for those, but they were used on projects across the corresponding regions. All of the catalogues that you see listed there are actively maintained and will receive updates and additions whenever required. But what if the design range you need doesn't currently have a Lineardraft catalogue? Well, in that case, we're always looking to expand the list of catalogues that we offer. We have an expert team responsible for creating new catalogues who are on hand to engage in that process, and this team will work with you to understand the design catalogues that you require, along with the scope of the components that you specifically need for your design, and then how you need those components to work in Lineardraft. So next I'm going to talk you through an overview of our process of creating new catalogues. This process consists of 4 phases which we apply to the creation of all new catalogues. Each of these 4 phases will be explained in turn on the following slides, but before we have a look at those, there's a few more points I'd just like to cover first. So as mentioned previously, all of the catalogues that we create are created in collaboration with the people who are going to use them once they're released. This allows us to ensure that the catalogue works exactly how you need it to. A common question that we get asked is, how long would it take to create X catalogue? As you can imagine, the answer to this is highly variable. It's dependent on factors such as the complexity of the design range itself, the scope of the items that are required, and the need for and complexity of any development work that's required to expand the functionality offered by Lineardraft. And one final point is that even though you may be able to provide all of the drawings for the proposed contents of a catalogue, early in the process, our team will look to gain direct access to that design range, and this is to aid our ability to carry out our own investigations and get more context on those items that are the proposed contents of the catalogue. So phase 1 of the catalogue creation process, this is the investigation phase, where our team will review any of those proposed contents for the new catalogue. Here we'll begin to establish the scope for the project that will result in the creation of this new catalogue, and this may involve communication with stakeholders to ensure that all of the basic items required for a functional catalogue are present within that scope. One of the key goals for our team will be to identify any challenges with this particular design range that we haven't encountered with any of our existing catalogues that we have available. These challenges could range from new types of equipment that we haven't seen before, up to the requirement for additional functionality that needs to be added to Lineardraft. An example of the outcome of this stage from previous project was our creation of the MTM catalogue, which was delivered in 2024. So during the first phase of this catalogue's creation, we identified that direct attachment of auxiliary wire support brackets to a gantry was functionality that was required and wasn't available at that time. At that time, it was only possible to attach SPS to then support a drop tube from a gantry. So this functionality was developed and implemented alongside the creation of the MTM catalogue. And as you can see from that screenshot there, we were successful and now able to directly attach those brackets to the gantry. Phase 2 is the collaboration and scope phase. This is where our team will communicate with the stakeholders over a period of time to report the findings of the previous phase. The proposed contents of the catalogue will be reviewed with those stakeholders to ensure that the scope of the project is fully understood by both our team and the stakeholders. Any development work that's been identified, this will also be discussed to ensure that any dependent items are critical for the catalogue, and also that the proposed functionality will meet the stakeholders' requirements and allow them to use those items as they would expect. By the end of this phase, we'll then be able to understand the resource requirements that will need to be assigned for the creation of the new catalogue. Phase 3 is where the initial production of the catalogue begins. So for this to happen, all of the necessary work will be split into a number of smaller work packages, which can then be tackled sequentially. The initial catalogue release from this phase will be focused on items that are required for early or outline design, and typically this will include the creation of masts, foundations, and gantries as a minimum. It could also include back ties, ornaments, catenary/auxiliary systems, and inspans, but this is dependent on the scale of work required for each of those groups of items. And then depending on how the work packages have been split up and the requirements of the stakeholders, there is the possibility that there could be interim releases for these additional items before we get to the final phase. So that final phase is what we refer to as the final production phase, and this is a continuation of the work packages that I was speaking about on the previous slide. Typically, this will include brackets, SPS, drop tubes, and both catenary and auxiliary wire supports. However, if any of the back ties, ornaments, catenary/auxiliary systems, and inspans mentioned previously haven't already been released, then they'll be included here in a final release. At the point of the final production release, all remaining items identified in the initial scope will be delivered, and this will include any items that were dependent on development work to be implemented, along with the required functionality to allow them to work in Lineardraft. So following that final production release, the catalogue status will then be updated to active. The catalogue will now enter a regular maintenance cycle along with all of our other existing catalogues, and users can now request any further additions or changes that they require. And this is the primary driver for further updates to the catalogue. Any additional items that are requested, they'll be handled through our catalogues roadmap, which I will link to later. And all of the changes to the catalogue are made by our internal team. This is to ensure that the catalogue works seamlessly as a final product. There is a list of complexities that are different for every single item type in a catalogue, and our team have experience working day in and day out on the creation and maintenance of catalogues. This puts them in the best position to make the changes that you need as efficiently as possible. So I hope you all have a better idea of the process for creating a new catalogue. I've put a list of our currently available catalogues back on screen, along with a QR code in the bottom right. So if you scan this, it will take you to a page on our Help Center that links to both the software and catalogue roadmaps. Please have a look if you're interested to see what changes have already been requested, or what we're working on now and in the near future. These roadmaps can just also be directly accessed through our Help Center if you don't have a chance to scan the code. So as mentioned earlier, if you need a catalogue that isn't on this list, please get in touch so that we can begin the process of creating a new catalogue with you. That's all from me. So thank you all for listening. And I'm now going to hand over to Matt.
Thanks, Tom. Okay, so yeah, what you've just seen about how the catalogues are created is really important, because it sets the foundation really for everything else that follows. Those catalogues aren't just visual placeholders. They're carefully developed ranges created in collaboration with design range owners and end users, so that every piece of equipment is data focused, allocation ready, and visually accurate. That means that when we move into project settings, we're working with assets that are both reliable and meaningful. So project settings themselves are where all of that information gets applied consistently across a project. They define the rules of a job. That includes the measurement of units being used, the default values for key design elements like mast lengths, foundation depths, wire heights, wire separations. If most of your project uses the same levels, then you set them once and you don't have to then keep adjusting them. It saves time, but it also removes opportunities for errors to creep in. They also take care of levels. replicating the information in the project seed files, every component, whether it's a mast, a foundation, or a wire, is automatically placed on the correct level. So there's no second guessing, there's no manual cleanup later on, and it's right at the first time of asking. Statuses are another key part of this. In project settings, you can define the statuses required within your workflows, whether it's proposed, existing, modified, or any other bespoke status that you might require. Every item can then be accurately represented. Combined with the level system, this doesn't just put the component in the right place, it also displays it in the correct color automatically. That makes intent instantly clear to everyone looking at the drawing. Beyond that, project settings adapt to the specifics of any scheme. Rail gauge, for example, whether narrow, standard, or wide, Lineardraft handles it. And then there's flexibility in how the information is displayed, the 2D symbology, the way the data is presented on drawings. Every region and client have their own requirements, and Lineardraft can accommodate them without compromise. So project settings are doing a lot of heavy lifting. They set the framework for accuracy, enforce consistency across the team, reduce repetitive manual edits, and ensure compliance with project or region specific standards. It's one of those areas really that works quietly in the background, but it makes the entire design process faster, clearer, and more reliable. Every project settings element that's been mentioned today is configurable, from default values, statuses, rail gauge, and it's all documented in detail on our help center, which is just one of the many support resources that we have available to all of our users. To go into a little bit more detail and talk a little bit more about that, and to give you a broader view of the full training and support offerings that we provide to our customers, I will at this point hand back over to Sarah.
Again, and I promised to short. So as Matt said, I'll talk about and really
Sorry, Sarah, just one second. We can't really hear you all that well.
Apologies, it's because I was
go.
trying not to cough into the microphone just a moment ago. Yeah, so as Matt said, I'll talk to you about training and support. I will try and keep it nice and short. The key thing to remember that is that when it comes to training and support, full support and training is included with every Lineardraft license. Whether you're just getting started or you're deep into a project, we will make sure that every user has the training and support they need, no extra fees and no surprises. So in terms of support, we offer it in a few different ways. So we have our help center. We have some of that in software support, which we looked at briefly in the demo. We have a ticketing system and we have training as well. So first and foremost, we have our help center. So there is a QR code on the screen. If you are interested, please do just have a scan at that. Have a little mooch around. It is publicly available. And this help center really is kind of your source of all information. There are over 540 articles on there, including how-to guides, explainers, so why do things work the way that they work in Lineardraft, and special use cases. So for some of those more complex pieces of equipment and things, special use cases explaining lots of different details. So if you have any questions, your first point of your first place to go really is usually the help center, searching in that search box, and you'll usually be able to find an answer. Along with the help center, then we've talked a little bit about the ways in which the software can kind of support you. So we looked at how we can get some prompts with suggestions of edits to make to our wire supports, for example, or we're able to hover over gantry length and things like that to be able to understand the maximums and minimums. So lots of little bits of support built in there. In addition to that, we also have the classic question mark in the top right hand corner. And if you click on this question mark in any window in Lineardraft, it will take you to a dedicated article on our help center, which will explain everything about that particular window. So for example, if I wasn't sure what name increment meant on this window on screen, I'd just click that little question mark and I'd be taken to an article telling me everything about this copy structure window. Moving on then, if the help center isn't, you've still got questions, you still need support after using the help center and the in software features, we have a ticketing system, and this particular ticketing system, we will get back to you. One of our team will get back to you within 1 working day of you submitting your ticket. So that can be if you have a question, that can be if you are requesting an addition to a catalogue, so the stuff that Tom was talking about, or it might be that you are reporting an issue. But our team will be there on hand to support you, and they will get back to you within 1 working day. Lastly then, just looking at training. So our learning team at the moment are rolling out a full learning management system. So this is an online platform with courses in Lineardraft, dedicated courses. So it's split into 3 main modules. That's Getting Started, Design Fundamentals, and Advanced Design. And the LMS will be going live at the end of this year, and every user will get an account. And once you've completed those modules, you'll receive certification, and you can even share it to your LinkedIn profile should you wish. In the meantime then, so that's going live at the end of the year. In the meantime, we have a Lineardraft training handbook on our help center. So this is a step-by-step handbook that takes you right from the very beginning of your Lineardraft, so right from getting started, takes you through all the different processes, and it is a written guide. In addition to that, we of course will offer online training sessions live with our learning team, or even visits to do some follow-up training and things like that should you guys need it, and you can request them on our with our support tickets as well. So that's just a quick overview of the training and support that we offer. But the kind of resounding feedback that we have from our users is that because of the intuitive nature of the software, generally that is all the support that they need. The prompts that are given in the software and throughout all of the workflows have meant actually that many companies have been able to start off their apprentice engineers or their graduate engineers with Lineardraft, and just kind of give them the software, tell them to get going, and they're able to use it. Having said that, we are here to support you in any way that we can and work with you to provide that support as well. So yeah, that is everything from me, and I'll just hand back to Adam to give us a little summary, but thank you all for listening.
Thank you very much, Sarah. And with that, that brings us to the end of our session today. So in this session, we've seen how Lineardraft is reshaping OLE design by driving innovation, enabling more sustainable and decarbonised delivery, and improving efficiency across projects. Our current case studies show just how impactful this can be. Furthermore, Lineardraft aligns with the United Nations Sustainable Development Goals, notably number 9 for industry, innovation and infrastructure, number 12 for responsible consumption and production, and 13 climate action, whilst also aligning with leading ESG frameworks such as SASB, the Sustainability Accounting Standards Board, and the GRI, the Global Reporting Initiative, notably GRI 302 for energy, 305 for emissions, and 306 for waste. Additionally, the automation that improves accuracy and reduces rework supports circular and lean use of resources, whilst enhanced collaboration and real-time updates strengthen governance and transparency elements within ESG reporting. The use of Lineardraft embeds tangible sustainability benefits into every project and even supports with tender processes where the sustainability agenda is accounting for an increased weighting in submissions, highlighting the importance of this across the industry, nationally and globally. And today we've seen how these outcomes are made possible in practice. A big thank you to everybody who's taken the time to join us this afternoon, this morning or this evening from wherever you are, and for the questions that we have received as well. Any questions that we've not got to, and even those that we have, we will collate and we'll share with everybody in the coming days. On the screen just here is a number of our QR codes where you can get in touch with the teams to begin your Lineardraft journey. Matt, do you have any final words to say before we sign off?
Yes, that'd be great if that's okay. Yeah, I just wanted to jump back on and echo everything that Adam's just said there, and thank you all so much for joining us today. It was mentioned by Sarah a little bit earlier on that there's been a lot of information to take in, and that we have only scratched the surface of what's possible with Lineardraft. So if you feel that this is something that will benefit you or your team, please do get in touch via the contact details on screen, and we'll be delighted to take the conversations further. For any kind of general inquiries, I would say you can contact myself or Adam. For anything relating to training and support, your best point of contact is going to be Sarah, and anything to do with design catalogues, then your best bet is to reach out to Tom. So yeah, there we have it. Once again, thank you very much for attending, and that's the end of our demonstration, and we hope you all have a great rest of your day.
Thanks everyone. Bye.